Hi, Michelin Math guys, welcome back. We're going to start by reviewing a little bit about the completing the square. I understand this is a difficult concept, so we're going to try to help you out with this by reviewing it a little bit more. So let's suppose I have 2x squared plus 10x equals 6. And I want to do completing the square. Well, first of all, remember that I don't want the 2 in front of there, so I have to factor out that 2. So I get x squared plus, and I've got to factor it out of the 10x also. So x squared plus 5x equals 6. And now I take half of 5x, which is 5 over 2, and square that, and that becomes my third term. So now I've completed the square, so now I have 2 times x plus 5 halves, quantity squared, on my left. Okay, so that's the whole idea here behind completing the square. You take half of this one, half of the center term, and you square it, and that becomes your third term. Okay, and then half of this becomes b, which is a plus b, quantity squared. That's how you complete the square and then factor it. But remember too that when we add something to this side of the equation, we have to also add it to the right side of the equation. Okay, 5 squared, or 5 halves squared, plus we can't forget about what's on the outside of the parentheses. So we've got, that's how we do a problem like this, equals 6 plus 2 times 5 halves squared. Now I'm going to have to do some work to simplify this. First of all, 2 times 5 halves squared equals 2 times 25 over 4, because I have to square this thing before I multiply it by 2. I can't just cancel the 2 and 2 and square 5. So 2 times 25 over 4, now I can cancel, and I have 25 over 2. And the 6 is equal to 12 over 2. 12 halves, of course, make up 6. And so if I add those two, I get 37 over 2. So this is equal to 37 over 2. Now, if I multiply by 1/2 on both sides, or divide by 2, that's the same thing. So that gets rid of that. And so it leaves me with x plus 5 halves, quantity squared, on my left, and 2 times 2 is 4, 1 times 37, 37 fourths on my right. Again, I'm going kind of fast. That's okay if you want to slow down and review this, or go back and redo it again. So now I take the square root of both sides, okay? And I get x plus 5 halves equals plus or minus the square root of 37 over 4. And remember, this means plus or minus the square root of 37 all over 2. Now, this is because I reduced the, I used the rules for radicals to reduce this, okay, or to simplify this. And so this, then all I have to do now is subtract 5 halves from both sides. And I have x equal to negative 5 plus or minus the square root of 37 all over 2. Okay, now I went through that just to remind you of how this stuff works, because now what we're doing now is we're going to talk about the vertex form. Okay, vertex form of an equation is like this. It's y equals a x minus h quantity squared plus k. Okay, well, what does it all mean? Well, let's start with a new page here, and we'll talk about this. Okay, if the vertex is at h and k, then the vertex form of the equation is y equals x minus h squared plus k, or a times x minus h squared plus k. Now you remember, and I'm going to pull this up a little bit here because just to remember this transformation of functions sheet that we did. Remember the vertical transformation, you add k. That moves your vertex up or down, or moves your graph up or down. Horizontal, f of x goes to f of x minus h. And that's pretty much what we're talking about here, x minus h. All right? So this goes back to, and if you don't have that sheet, you want to print that out again and make sure you got that handy. Okay? Also, the vertical stretch or shrink has to do with a. If a is greater than 1, you have a vertical stretch. Okay? If a is between 0 and 1, you have a vertical shrink. Okay? So that's just a reminder of all that stuff. So let's try a actual problem here and see if we can work with this stuff. Okay? Suppose g of x equals 2x squared plus 12x plus 13. Okay? Well, that means it equals 2 times x squared plus 6x plus 13. Okay? So all I've done here is I've taken this part of it and taken a 2 out of each one of those terms, and I've left a space here so that I can complete the square. And then I add 13 on the end there. I haven't changed anything, I've just factored out 2 things here. Now, what's half of 6? That's 3, and 3 squared is equal to 9. So I've added 9 here, and I have to add, excuse me, I don't want to add it over here because I'm on the same side here. I'm not going to 2 different sides. I'm on the same side of the equal sign here. So I added 9. No, I didn't. I added 2 times 9. So I'm going to subtract 2 times 9, okay, or 18. And now I'm going to simplify this and say, let's see, 2, and x squared plus 6x plus 9 is x plus 3 squared. And then 13 minus 18 is minus 5. Now I'm going to put it into vertex form. So that means I want y equals 2, a equals 2, times x minus negative 3. Say, well, why did you do that? Well, look at my vertex form, x minus h. So h is equal to negative 3 squared plus negative 5, because I have plus k here. Okay, so h equals negative 3 and k equals negative 5. So the vertex is at negative 3 comma negative 5. The line of symmetry, their axis of symmetry, is x equals negative 3. You know, this is your x. This is your x up here. So your axis of symmetry is x equals negative 3. Okay? And, of course, a equals 2. So what you have here, if you're going to graph this thing, okay, your vertex is at negative 3, 1, 2, 3, and negative 5, 1, 2, 3, 4, 5. So here's your vertex. A is positive, so your graph opens upward, and oh, that's a really ugly looking parabola, but you get the idea. It opens upward, and also you've got a shrink, a vertical shrink by a factor of 2. And we're going to graph this thing to find out how that works in a moment here. There we go. There's our graphing calculator. And clear out whatever I have there. And go up here and I say, I'm going to put the original, I always like to put the original one in there, 2x squared plus 12x plus 13. So 2x squared, x squared, plus 12x. By the way, when I put the original one, if I get something different than this, then I know I've got to look for some mistakes here. Okay? If I made a mistake somewhere from here to here, and I put this in, then I may have made a mistake somewhere, and it might not match this one, and I wouldn't know that. So 2x squared plus 12x plus 13. Now I'm going to graph this thing, but before I graph it, I've done some other things in the past. So I want to start with the Zoom standard, number 6. Okay? And sure enough, that looks like my vertex is right there at -3 and -5. Just to make sure, I'm going to say second calc and minimum, because my vertex is a minimum. Enter. And I want to move my cursor to the left to identify the left boundary. Enter. Move it to the right of the vertex to identify the right boundary. Enter. And then enter again. And there's my vertex at -3. Just ignore the 0.00001. -3 and -5. That is my vertex. Okay. And so, sure enough, I've got a good solution here. And just remember that the transformations here, we've got a vertical stretch by a factor of 2. Okay. We've got a horizontal transformation, 3 units to the left. It's -3, so it's 3 units to the left. Okay, and +5 is my K, or my vertical transformation. So I'm doing down 5 units. Okay, so that's how I end up with a vertex here. And that's all I got for you today. We'll practice some more of this stuff and answer some more questions in class. Thank you.